Welcome to an ongoing presentation of educational videos. Geometrics is proud to discuss today one of our free processing programs called MagPick. And specifically what we're going to investigate today is how to make an analytic signal map. So analytic signal has been discussed in one of the prior videos having to do with the use of transverse gradient data from two magnetometers. We measure the transverse gradient. We also measure the longitudinal gradient along the track, and then we compute the vertical gradient and use the square root of the sum of the squares to produce an analytic signal map. So I'm going to show you today how to use MagPick and data from a transverse gradiometer. This could be on either land or marine, and we're going to take the data, explore the layout of the data in the Interpolator file generated by our MagLog program, and then I'm going to show you how to use this data to create an analytic signal map in our processing software MagPick. So I'd like to start by looking at the Interpolator file, which is generated by MagLog. So MagLog is a PC program that uses data from the magnetometers, in this case two magnetometers. It also uses input from the GPS, which is mounted on the boat, of course. And then we also have the amount of cable deployed. So I'm going to show how this Interpolator file is set up so that when we do bring it into MagPick, we know which files, which columns in the file are used to inform the program of the position of the sensors and some other information that I'll point out. First of all, we'd like to suggest that you have a good text editor, and it was recommended to me that we use a Notepad++. Now you can use a standard Notepad that comes with Windows, but Notepad++, which is an open source program, has a lot more features that enable us, for instance, to see more of the file on the screen at one time. And Notepad++ is available at soundforge.net. So this is an open source replacement for Notepad. It's called Notepad++, which gives us some additional features. So I'm going to take the interpolated file, which is called, which has an extension .int from MagLog, and I'm going to open it with Notepad++. And what we see here are many columns of data, which I'm going to explain. Each of these columns has a header, has header information. And so, for instance, the first column is Mag1. The second column is Signal 1. So that's the signal strength of magnetometer 1. Then we have the depth information, the altitude off the seafloor, which comes from the transverse gradiometer array. So there's an altimeter mounted on the TVG. Then we have Mag2 data, Signal 2 data. We have the depth of the second mag. We have the altitude again, which is actually the same data that's in, we're going to use altitude 1. Altitude 2 is just a replication of that same data. Then we have Mag 3, which is the difference between the two magnetometers. So this is the unnormalized gradient. Then we have the date, the time. We have GPS long, GPS lat. These GPS columns are for the position of the antenna on the boat. So these do not reflect the position of the magnetometer sensors. We're going to compute, those are computed in real time by MagLog, and I'll show you where those are in this Interpolator file in a moment. So we have GPS long, GPS lat. Then we have shifted long, shifted lat. Now this shift point is actually the point directly behind the GPS antenna. So it is the length of the deployed cable plus the distance from the GPS antenna to the back of the boat. So This is not the position of the array because the array will often be towed off a winch or off a sheave wheel. And so those are actually the next columns, which are listed as lawn mag, lat mag, lawn mag 2, lat mag 2. So actually during the process of setting up the logging software, we tell the program what the separation is between the sensors. And so this Interpolator file is created in real time by maglog, and the positions of the individual sensors are computed in real time at 10 times per second. So this lawn mag 1, lat mag 1, lawn mag 2, lat mag 2 are the actual positions of the sensors towed on the array. And we do that by telling the program what the lateral offset is from the tow point, what the linear offset is from the back of the boat, plus the length of cable that has been deployed to the array. So as we can see, there are many columns of data, but only some of them will be used. For instance, we'll be using the mag 1, the mag 2, we'll be using the mag 3, which is the difference. We'll be using the altitude 1. We'll be using the GPS positions for the actual sensors, which is called lawn mag 1, lat mag 1, lawn mag 2, lat mag 2. And then after that we have some additional GPS information having to do with the quality of the data and so forth. And finally we do have the line number. So this is the recorded line number that we have set up in maglog, and last we have the layback. So this is the number of meters that indicate the distance from the back of the ship to the array. So this is the number of meters of cable that we have deployed.